Hello. Today we are going to talk about linear probabilistic modeling and go over a brief, real-world example. Linear probabilistic modeling is used to determine a dependent variable value, y, based on a given independent variable value, x, as well as the probability of getting a different y value. It starts by making a linear regression of a sample of data. Using the linear regression line, y equals beta naught plus beta 1x, we can determine y for any given x. However, no model is perfect, so there is variation in y. This variation is called epsilon and is normally distributed with mu equal to 0. Positive epsilon is above the regression line, and negative epsilon is below the line. This is added to the regression equation. As you can see, for each point on the regression line, there is an epsilon distribution. For an estimation of y, given an x value, you would plug x into the equation of the line using the estimated value of epsilon, which is 0. Then you can go one step further and test that x value experimentally. If the experimental value of y deviates from the theoretical value, then a z-test can be used to determine the probability. This can be used in a hypothesis test to see if the model is fit for the population, on top of the coefficient of determination, or r squared. A real-world example for civil engineering comes from a torsion test done in a mechanics of materials class. For those who don't know, in a torsion test, you use weight to twist a bar and measure how much it rotates. In this experiment, the force applied and distortion were linearly regressed to compare the theoretical value of shear modulus, or G, to an experimental value. If this experiment were continued further using linear probabilistic modeling, the rotational distortion could be determined from the applied force, and the epsilon distributions attached could be analyzed. This can be used to determine the strength for a certain population of materials. Knowing the torsional strength is important for obvious safety reasons. This example is just one of the ways that linear probabilistic modeling can be used in the engineering profession.